Okay. So for the recording, welcome team. Today we are going to explore the Apache Airflow. Um, and I will talk about what Airflow is and how we will kind of do a installation to do for a demo and how a Airflow DAG works and how it is used, right? So basically, what is Apache Airflow? Have you all, I think most of you must have used some kind of orchestration tools, right? Or heard about orchestration tools. The most basic is the cron job, where you schedule the jobs at a particular cron schedule. Cron is a utility, Unix utility that keeps a daemon process checking at a particular time and then trigger the job at that time, whatever you have scheduled. So there are a lot of orchestration tools in the market. Autosys, uh, I don't remember a lot. There are a lot of them that uh, we have worked with, but most latest one, even Databricks that we have looked at has its own Databricks workflows. It's kind of a scheduler. AWS glue jobs you can schedule again automatically. It has its own scheduler. So all of them have schedulers, but Apache Airflow is something that has a lot of features, and it was developed at by Airbnb initially, and later they have outsourced it. So as we said, a lot of these top five or companies have built some of these tools, homegrown tools, and then they have open sourced it. Like we said, the Kafka was built by LinkedIn, and then it was open sourced, kind of. So something like this, it's an open source platform to programmatically author, schedule, and monitor the workflows. So you can create, you can schedule, and you can monitor the workflows. What is the workflow? Basically, is whatever jobs that you create, like Databricks notebooks that you have created. You package it as a job to run at a particular time, to execute at a particular time, the batch jobs, right? So you want to schedule hourly, or you want to schedule daily, or you want to schedule weekly, whatever it is. So you want to schedule that jobs and then monitor whether they have run at that time, whether they have failed or they have executed successfully, how much time they have taken, if you have any warnings, what are the warnings or messages that it has logged, how many records, statistics, how many records it has processed, how many it have passed, how many have failed, what kind of error, if there is error, is the error logged, then are the notifications working, have you if the job failed or if it's successful, if you have configured, is it sending out an email notifications or Slack notifications or Teams notifications, whatever you have configured. So all of that comes under the monitoring. So you can create, schedule, and monitor the workflows using Apache Airflow. Airflow can work with any of the other tools, any of other platforms to schedule it. So how it is, what all its components, that we will go through in detail. So as I said, it's developed at Airbnb. Now it's part of open source software foundation Airflow. It uses DAGs to manage task dependencies. What is a task? We have done this, right? Even in the Spark, we have looked at DAGs. So directed acyclic graphs. So it is a directional acyclic. It does not go back in a cycle, and then it executes based on the graph that it has generated. So just like a Spark DAG, Airflow also has called as DAG. We create a DAG in the Airflow and then use that to execute. So it creates a dynamic workflow definition in Python. Basically, Airflow is written in Python. So you create a DAG in the Airflow using Python coding language. So that's in Python. So that's why we have been stressing upon Python is very important for we do PySpark, any data engineering, or you do data science, or you do Gen AI. All right. So Python is the most preferred language currently, because of various factors. The simplicity or easy to learn, easy to code, these community support, the number of libraries that are available in Python, everything that is out in the market has a Python library that can be installed and used, in Python. So rich UI to monitor, trigger, and troubleshoot the DAGs. So Airflow has a rich user interface where you can monitor, trigger, and troubleshoot the DAGs. It's a pluggable architecture. It has support for various executors, operators, and sensors. We will see what is an operator, what is a sensor, what is executor. We'll go through it. Scalable and extensible with plugins and APIs. So you can have a plugins and APIs that you can use within the DAG. So how does a DAG look like? Uh, a Airflow DAG. So you can see here, you can import just like it just looks like a Python code, Python program script. Okay. From Airflow, you import a DAG, task, bash operator, whatever. We'll talk about this. With DAG is the basic represents a workflow. Okay, in the Airflow, whenever you run it, the basic structure, foundation, building block is a DAG. Without a DAG, it will not run. So you have to create a DAG object from DAG only, just like a main method. When you create a Python script or when you create a Java program, you have a main method. Similarly, you will have a DAG. Now in the DAG, you can give some default parameters, or if you want to have a DAG ID, date time. A schedule here you can see. So this is the cron schedule you want to give to run this DAG automatically. Later you can also modify it using in the UI, but basically if you want to give a default parameter, this is how you can give the schedule. Now what is this 00 star star star? This is a standard way of describing a schedule for the cron job, for a cron schedule. And any of you have seen this earlier? I think at least Anshu, you must have.
Yeah, madam.
Sorry.
Yeah,
Yeah, you looked at it, right? You understand what is a
yeah,
DAG.
yeah.
And who else we have? Yeah, Nabi. Nabi must be working day in, day out with the schedules in the production support, right, Nabi? I don't know if he's unmuted. I think he's just come back from work, so that's fine. So, um, so that's the basic, schedule, cron schedule. What it does, it gives you the representation. We can dig deeper and see what it means. But it basically tells you day of the week, hour, minute, seconds, or hour, minutes kind of a thing. When you want to run this job, that schedule is all encrypted in this 5-digit format. Okay, so each digit has a specific meaning that we can look at. So let's see if we want to quickly go here and say cron expression. Okay, what does a cron expression mean? What is a cron expression, right? So it's a string consisting of 6 or 7 fields that describe individual details of the schedule. What does that mean? If you put like this, it causes a command to run at 4:30 a.m. It's hours, minutes on the 1st and 15th of every month plus Friday. So something like that. So you have it's a complete expression, just like your what you call matching expressions that you write. Similarly, a cron expression, it has a meaning that you can create. That's besides the point. That's part of it when we want to schedule the job using the cron schedule. Okay. Let's come back here. So that is the schedule you give as a DAG. Okay, this is the class. And then you create tasks in the DAG. So DAG will consist of a collection of tasks. At the end of the day, what it runs tasks, right? So the DAG is, it is generated and it has tasks, and then you create dependencies between the tasks. That's how you create the DAG. So you have bash operator. So it gives you, so when you're creating a task, so each task can use a operator. So what do you mean by operator? So my task can be a Python function. Okay, the first task I want to run as part of this workflow can be a Python function or a Python script or a just a command that I want to run in the terminal. Okay. Um, or it can be a Databricks job, Databricks notebook, whatever it is. So you can use this as your operator to create a task. So here, hello is a task that I'm creating. The type is bash operator. It's a bash operator, right? A command bash. You have these in the Unix. You have the shell, bash shell, corn shell, kind of a thing. So something like that. It's a bash operator. It has a task ID. So I'm giving a task ID and the command that I want to execute on the terminal. So what is the command? Command is echo command. So when you do echo hello on the terminal, what does it do? It just echoes. It says hello. That is the output. Now what I'm saying here, hey, hello is a task which uses bash operator, which is of type bash operator, which means it will run on the shell command. What is the shell command? Echo, hello. So I can write any shell script command here. I can run a shell script completely using the command prompt here. It will go and run that on the shell, Unix shell. If you want to do any file operations or list operations, delete or whatever you want to do, create folders, whatever, you can just execute your bash operator. Then there is another task you can create by declaring it's a Python function called airflow, which is just printing the airflow. Okay. So now this is the task. Now what I'm doing, I am setting dependencies between these two tasks. What are the tasks? One is hello, one is airflow. So I'm saying hello, bit shift operator, and then say airflow. So first it will run hello task, which means it will go here, figure out, hey, it's a bash operator. So I have to run a bash command on the shell and it will take this and run on the command. When it is successful, so it will come back and say, hey, this is successful. What's next? Hey, next it's a airflow. What is that? It's a task, but it's a Python function. So you just go and execute the Python function, whatever it is here. So what it will print, hello will print hello, airflow will print airflow. This is the structure. It's very high level. Don't worry about all of the syntax. I want you to understand what it looks like and what are the components. We'll go dig deeper. Now I said, any questions on this before I move forward? Anirudh, Rahul, Anshu?
Yes, sir.
No,
Yes? No? Somebody said yes. Any questions?
no questions.
Okay, fine. Now see. Okay. So I said airflow will have, it has a rich UI, right? To go through, monitor and execute. So this is the how the Airflow UI looks like, where you can see all cluster activity, data set security, browse admin, all of that. And then you can see the graph of your DAG. So it looks like this. It says, see, for the first one, unfortunately, these are all bash operators. Print date, sleep, templated. These are three different tasks. Once the print date first task is success, then these two are running in parallel. There is no dependency, but both of them are dependent on print date. Only when print date is success, then it will trigger the sleep task and this templated task, both of them. But they can run in parallel. There's no dependency. Then you can see what are the failed tasks, deferred. So these are different color coding to show which are successful, which are failed. You can see the charts here. You can get details. You can look at logs, time. All of this is available in this dashboard. Okay, task duration and all of this. So this is how the UI looks like. And if you dig deeper into this, so you can see hello airflow, that was the sample program when you run. So it will show you basically. Okay, I cannot zoom this further. Um, so it will show you when it was run, what are the date times, um, status, task ID, what is the run ID, operator, what was the operator for each task. If you select, it will give you all the details of that task here: upstream, downstream, past, future, task instance details, log, all runs details. Everything is here. Okay, you can go through very each and individual task and details of that what it does. So what is the architecture of Airflow? When we talk about the Airflow architecture, we talked about it has DAGs, right? So I write a Python script as a DAG. So where does it go? It has a DAGs folder. All of that is stored in a metadata database. It stores, hey, this is the DAG, these are all the tasks, this is the scripts, everything, and this is the dependency. It will store here. Scheduler is something, it will go and check to see what are all the tasks that has to be run, like a daemon process. Every minute or every second, it will go and check, is there any job, any DAG that is ready to be run now? What does it do? You have already given the schedule of your DAG, and then it will compare with the current date time and see, hey, if it matches, then it will schedule that, it will start execution of that DAG. So that is the job of the scheduler. Now executor is a scheduler will just schedule to run. So what will actually run is your executor. So executor will execute the job, but executor is just like master. Now it will kick off the job, and then again it will have some workers to do the actual job. So these workers can be in talking to any of these your things to run this job. To go and if it is a Databricks job, it is a DBT or Redshift, S3, all of this it can connect based on what kind of task that you are executing. And then you have web server, like that beautiful UI, whatever you have seen. So that you need to have a web server to view it on the web, all of this stuff. So these are the main components. You have metadata where it stores all the DAGs, a scheduler where it scans and lets you know when the job has to run, the executor which will run the job and utilizes the workers to execute, and a web server to view the UI on the web. Okay, so this is the high level architecture. Now we talked about scheduler, executor, web server, worker, metadata. So DAGs are parsed by the scheduler to determine task execution schedule, when it should execute a DAG. And then executor will handle the task distribution to workers. So it will distribute the work always, right? So workers, just like a master and worker cluster thing. And web UI for monitoring and management. So this we have already done. DAG is collection of all tasks you want to run with dependencies. Each task is a node and dependency is an edge. So you have tasks and dependencies as the edges connecting those nodes. And then these are defined in the standard Python files. We also talked about what is web server. It's a Airflow web server provides graphical interface for users to view and manage workflows. So whatever workflows you have created, the DAGs, you can view them and manage them on the UI. And is responsible for displaying the status of DAGs and tasks, as well as allowing users to trigger DAG runs and view task logs. So if you have a schedule, it will run automatically. But if you want to run manually, okay, ad hoc runs, you can also do that from the UI. So that's right, there's the web server. It has scheduler is the one. Again, this is all repeated information. Scheduler schedules diagrams and create tasks. It monitors metadata database to determine when to trigger new diagrams, and it creates tasks based on the DAGs dependencies. Metadata, as I said, it stores all the DAG information. So this can be any of the SQL, Postgres, MySQL, or SQLite, any of the databases you can use as this. So executor will just skip it for now. It has it works with 3 different executors like local, Celery, and Kubernetes. You can use different types of executors, just like you are using different types of databases as metadata. So executors also, you can use different types of clusters to execute the jobs. Now we were talking all of this, then we said we looked at bash operator, right? So we looked at here and said we created a bash operator here. So we said imported bash operator, which runs the bash command. Now, what are the different types of operators that you have? What is a bash operator and what are other operators? So it gives you different types of operators. Some, for example, like bash operator, we know. Python operator, which is basically your a Python function or your Python script that you want. Email operator, if you want to communicate, send out an email or whatever it is, and dummy operator where you can create your own operators on that. You can also create a extend your base operator. You can have there is a base operator, but you can create your own operator extending the base operator. Now let's look at what is operator and what are the providers. Okay. So if you go here, so what are the operators? There's a bash operator. There is a Python operator. DAG dependencies. In this, you have sensors, branch date time operator you have, virtual environment operator you have, external Python operator. So all of these, and then so how you use it. So you have a HTTP operator, you have an email operator, okay, bash, Python, email, and you can use @task over the Python operator to execute Python that we have done. Okay. There will be a list of operators that you can use. So in the documentation, how you use Python operator, you can use like this. Okay, Python callable is what is your function, or you can directly say @task for this Python operator as well. Okay. So let's go here. So if you go to Python operator, you can say @task, you give the ID, and then this is your function. What is called your task. So your task will be called same as your function name. And then you can pass any number of arguments to these. So it's a standard Python function you write, and then you provide it, you give it use it as a task. Okay. One second, let me give you. And the next thing, apart from operator, to build this is the provider packages. Okay. So to give the operator, we have seen bash and Python operator, right? So all of these providers have provided their own implementation of the operators. So we have seen we can go to any of these, import any of these, and use the operators using any of these providers. If you see Apache Spark, Spark will provide a library, airflow.providers.apache.spark, a Python package. And these are the versions required. So you can start using these packages from these providers. So all of these providers will give you the connectivity to Airflow, where you can start using. So you have Docker, package, and then you have MongoDB, Apache Spark, GitHub, Google, all of this. So you can connect with any of this. Even OpenAI has, you can connect to OpenAI also from the Airflow DAG if you want to create a task with the any of the OpenAI if you want to use LLMs here. Okay, so we can explore this. I think these are all the same, packages, installations, same stuff here. Operator. Now let's see S3. Look at this. So if we go to Snowflake operators, right? So we said there are different operators, right? If you go to Snowflake operator, it gives you Snowflake gives you 4 operators. I'm just giving you an example. S3 to Snowflake, just Snowflake operator, Snowflake SQL API operator, Snowflake to Slack operator. So if you just say S3 to Snowflake operator, it's a specific implementation where you can directly use. It will, when you run the task, it will automatically move your data from S3 to Snowflake. These are the implementations provided by the providers. That's what I was talking about. What's this? Okay. S3 to Snowflake operator to load data stored in AWS S3 to a Snowflake table. So what do you need from S3 to Snowflake basically to connect? So you need the credentials to connect to S3. You need the credentials to connect to the Snowflake source and target, just like what we are doing in Databricks or whatever we are doing in ETL. There's no transformations. It's just moving the data, copy data, right? So similar to use this particular operator, what you need is when you use this operator, you give Snowflake connection ID where it has to connect to the Snowflake. You give the S3 keys to connect to the file path. What is the table and what is the stage in Snowflake, and what is the file format and pattern. And then when you run this, it will automatically connect to S3 using the S3 file path and the keys and the connection ID, so it can pull the data. So it's basically you have so many of these operators which are provided by these providers, which you can use when you are creating the DAG. Are you guys following me, or I'm confusing you with the operators and providers? So basically providers are like your platforms, say Databricks, Snowflake, AWS, Azure, right? All of this, whatever you call, MongoDB, Oracle, each corporation, each product, they are all providers. What they are doing, they are providing a implementation so that Airflow can connect to their environment. That implementation is called operator. So providers will give some operators, implement some operators and for the Airflow, where you can just import those libraries and use those operators to connect to those products. Clear?
Yeah,
Anshu?
yeah.
Okay.
Yeah, Harun, it's clear.
Yeah. So the two things, providers and operators. Okay. So those are the things. Now you can go and check what are the different operators and so these things. Now what we have seen here is the operator. Operator is like task to create a function. So when you run this, it will do. Apart from that, Airflow also provides something called sensors, okay, and hooks. Basically, sensors are a special kind of operator that waits for a condition. Sensor, like it sense. It's just like, you are waiting for event. You are waiting for something to happen. For example, if you use a S3 sensor, it will wait for something to happen on that S3 folder bucket, which means, like, say there's a new file that is coming to the folder. Immediately an event is triggered, and then you run the task. So that's the kind of sensor you call. It's just like waiting for an event to happen. Hooks are like, again, abstract external systems that you have on S3 or MySQL. It's a different implementation that we will talk about. So they are used for external integrations and checking the data availability for that. So those are the concepts that we talked about. When to create a DAG, we said we need airflow. We need to create airflow DAG. It's written in Python. We need to create tasks and dependencies between those tasks. To create the task, we can use operators, and those operators are different types. It can be a bash, Python, or any of the S3 or those kind of operators. And those operators are implemented or provided by the providers. So this is all about what to do to create. Now, to create actual DAG in the environment, what you need, right? So I need a Docker, basically for the demo purpose, because we are not doing it on the cloud or any of the environment. So you can create a Docker container. I know if you are aware of what a Docker container is. It's just like a shipping container where you can put entire your application inside it and pack it, and the entire, just you can move that container anywhere as is. You can put it in Azure, you can put it in AWS, you can put it on your laptop, you can put it on the on-prem server, wherever it is, it will behave in a same fashion. Once you package the Docker container, you can ship it anywhere, you can deploy it on any environment, it will behave same. Okay, it's platform agnostic. So that is why Docker is very famous, particular. So you can put your entire application, including your operating system, and create a Docker image, and you can just publish the Docker image, deploy the Docker image on any of the cloud, on-prem, laptop, whatever it is, and then you can interact with that application inside that Docker container. So that's at a very high level, what a Docker container is. So first thing you have to do is create a Docker desktop. So this is my Docker desktop here. So you have to create a Docker desktop with the user settings, whatever user ID you give. Create a Docker container. Docker container. First thing. So you go here. Don't choose a plan or whatever. Just say download Docker desktop. And then you can download for Windows, AMD, ARM, whatever is your machine, laptop. You can download the Docker desktop. Okay. So this is the step one that you need to do. So basically, once you do the Docker desktop, you see here, there are two steps for the Docker Hub. One, creating a Docker Hub, Docker image, and then creating the containers. So Docker image is what type of application you are creating. So I am creating a Airflow. Okay. So Airflow already has a Docker image created, like a template or like a class. The template is on the Git. So we will pull that image from the GitHub onto this Docker desktop. Then we will create our own container from that image for our use. So these are the three steps. First, create the Docker desktop, then pull the image, then create a container. Okay, three steps. Now, first step I have done, created the Docker desktop and started it and logged in. The next step to do is pull the image. For that, what I'm doing is I'm creating a folder in my local called Airflow. And from here, I'm opening my I'm, terminal. So you have to create again install another software called Visual Code. So first is Docker, next is Visual Code. I have given here. First is the Docker, next is the Visual Code. So these two software you have to install, then you have to build the Docker image. Okay. So what I need, so I have installed the Docker first, then Visual Code I have also installed. So I'm just opening it from from my folder. I just say dot code. It will open the Visual Code, or you can directly open the Visual Code. Forget, don't look at all of this stuff. So this is all created. Don't worry about all of this: web server, config, PID, CFG, DB, blah, 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 all of store, standalone admin, everything. Don't worry all of this. Just go here first in the Airflow, create a folder called Airflow. In this, first create a file called Docker file. The name itself should be the Docker file. In that, I am pulling the Git from Git. I am pulling the Airflow Docker file image. So once I put this content in the file and save, and then I can right click on this and say build image. Okay. So then it will start building the image and to my local desktop. Containers. Just should be somewhere. Did it run? Okay. Why is it asking this here? And does this right? Okay, that's fine. Okay, so we have a Docker file, and then I have another file called docker compose.yaml. These are the two files that I need. So first one is a Docker file. The second one here is the compose file. That's what I'm creating a instance image of that. I will give you the contents of this. You can just copy the same, but make sure you use the names properly. If the name is different, it will throw errors. Whatever you are doing, so use Airflow, user Airflow here, and this image name you can change to anything. Okay, run service and this name, and then rest all you just leave as is. Okay. Latest, we are pulling the latest image and naming it Grok Airflow : latest from that. So once you have put these two files here, first I will go to Docker file and then build an image. So it will ask here, is this the name that you want to use? Just say enter. It will start building the file. Okay. So this is unpacking. This is done. Image containers. Okay, see here, you got your image right now. Okay, the next thing is to build the container from the image. So you go back here, go to Docker Compose YAML, right click and say compose up. Okay, then it will say container Airflow Grok Airflow 1 started. So you can go here now and look at containers. Then you see your Airflow image, Grok Airflow, it's in here. So this is running container. Okay. Now when this is done, the next step is to go and create a DAG here. So what if you see here, what I'm doing is I'm creating port 8080 that is talking to the same port on the Docker container. Okay. So now I can use localhost 8080 to talk to the web server for the Docker image. And then you will get the standalone admin password here as well. It is generated. So you can use that to do that. So, and this is the DAG, actual DAG that I have created. So maybe I'll just take this and open. Just copy this here. And I will delete this. Okay. In the DAGs folder, I will create new file. DAGs test.py. Now I can go here first and then say localhost colon 8080 and see my welcome underscore DAG is the previous one that it has already read, recent tasks, all of this. So what I will do, I've created a new DAG here and paste this and save. Can delete this from here. Okay. Now I have saved this. So it will take about 4 to 5 minutes to get refreshed and then it will appear here. By that time, we can go and see what I have done here. So I just imported DAG from operators. I imported Python operator, but I'm just using the Python functions. Print welcome is one function. Print date is another function. Print random number is another function. I'm not using this REST API. I think it has some issues with this ID. So I created a random int. It will generate a random number. So these are the three functions. So I created a DAG called welcome DAG, default arguments and schedule interval I have given. So for this DAG, I have created the operators. So print welcome task. This is my task. So here what I have created is only functions. Okay. But it has not registered as a task yet. So I'm using these functions to create task. Print welcome task is my first task, which is a Python operator. And what is the callable function is a print welcome. So this is your function name. So you should have a print underscore welcome function that will be associated with this task. Print welcome task is a Python operator. Similarly, I have a date task, which is again a Python operator. So Python function or Python callable is print date, which is this function, print date function. So it will execute this date time today. Then I have final another task called random number task, which is again a Python operator, which means I can have a Python callable function, print random number. That is my function here, which will print a random number between 1 and 1000. Okay. Now I have defined all three tasks. I have to define the dependencies. So I will say first execute the welcome task. Once you execute this, when it is successful, then execute the date task. Once this is successful, then execute the random number task. So these are the three tasks that I have given it dependencies in the DAG. Now, if we go here, see now I have got a welcome DAG. Now, don't confuse with the name of the script here because it will always identify with what you are calling it here, the DAG. Okay, it's called a welcome DAG. So this is what it is showing here, welcome DAG. Fine. Now click on this welcome DAG. Yeah, go to graph. See here, you can see a graphical representation of your tasks. Print welcome, it is a Python operator, then print date, then print random number. So if you have 2 or 3 tasks, then it will change. Okay. We can try that. First, let's complete one full cycle, then we'll come back. So this is the task. It's not relevant. There are no event log yet. You know, I think these are the old ones. It has run earlier. It has saved all of that stuff, I believe. Now I go back here, welcome DAG, and then you run. Manually, you can run it. Okay. So now it is showing here running one. Then it will show if it is failed. It will show if anything is failed here, success here, queued here. When this was last run on 4/18, it's basically now, right now. It is just showing some other date timestamp. Okay. So recent task, this is the same thing. Old ones. Success. So this is a success. If you go here, it will show total success. See. Print random number is here. Event is a success. Details. Description. So these are all the details of the run that happened. Then if you click on this, it took 7 seconds, 6.61. Python operator, all success. Where is this thing? Success, this is success. Where do I see this? Code read. just print welcome event log 418. This is the latest one. This is the host. This is full command showing. These are all the events that have happened. Okay, I think I forgot where I look for the output log. The console print statements where it is written to console. I have to check that log. I'll let you know where that log is. This is the code that it has run. Just like from the file, you can see what if you have if you think there is some issue with it or you have changed something but it's not updated here, you can always check the code what it has executed here. Okay, what is the graph and what are the details, all of this. Okay, so that's the how you create a DAG. Okay. So it is using SQLite as metadata, but in production we can use any of the using they recommend Postgres or MySQL. Do not use sequential executor. That is fine. Okay. I will check that. That's fine. That's a simple thing. I'll check and let you know. But that is the whole process. Now you can use any of this in the tasks, right? You can use any of these things that you want to create, any operators you want to use. So it's basically just importing those libraries, and then if you have a Databricks job, you have to give the connectivity to Databricks to connect to Databricks, import that operator and then give the job name and all of that. That you can do for that. Okay. Now I will give you all the configuration what you need to do, to connect, and also the reference videos that you can go through to set up this. If you want to try the creating this demo for Airflow, but at least you should know how all of these things are connected. What is an Airflow, what is a DAG, what are the tasks and what are operators, how do you define dependency between the operators and all of that. Okay, so that's about the demo. Any questions? You have any questions in this demo?
Not now, Arun. Maybe later.
Okay, yeah. So most of the times get some issues when you are installing the Docker, bringing it up and getting the image and containers here using the visual code. But most of the things you have to look at is what user you are using here, and what is you're giving the command ports. All of this, keep it as same, close to same what we have here. The service thing you can change this image name and the run service thing. You The file will not have this run service thing. It will just have services and the name and image and all of this. So this name you can change, this name and this name you can change, but rest of all of it keep it same. These two, and then you can create, and then you can create the only after you see the container and images and containers here, image here and the containers here, and see if these are running. then you go to the next step, creating the DAG here. Okay. So once this is running, you can go to your browser and then start the UI. Okay. So you just go, as I said, localhost ::8080/home. You should get this Airflow UI. That which means that all your configurations are all correct. Then you go and create a DAG here. So when you create a DAG in this DAGs folder, Airflow DAGs folder, it will take some time to sync up. 4 to 5 minutes, it will show up in the UI. Okay. So once you show up in the UI, then you can run it from there. Or if there is a problem with this DAG that you created here, then it will show up here as an error that it cannot parse the DAG or whatever issues in the UI. So you can simply delete that and then go here, make changes, and then save it and then wait for it to come there and see whether it has successfully parsed or not. But at least make sure you understand all of these concepts. These are very important, like operators and dependencies to build the workflow. So what kind of operators are available, what kind of providers are available to do this task. If you want to really explore, you can use the S3 to Snowflake operator. You have your AWS S3 connection, figure out the connection properties and then Snowflake properties and try running the DAG using that. It's kind of taking it too far, extending, but at least understand all of these concepts. All right. Okay. So that's about the Airflow. Let me stop recording